Oops, let me get my slideshow up. Sorry about that. There we go. Section 1.10 is our trigonometric functions. So basic sine and cosine functions, we have looked at these before. In this case, they have done sine is in red and cosine is in green. So we can let's look at sine first, the function that's printed in red. We have a period length from 0 to 2 pi, and within that period we complete one cycle of the function, and then the function begins to repeat as it goes on. So the period length for both of these functions is 2 pi. The amplitude, amplitude, which is the distance from the center to the top or the center to the bottom. The amplitude here is 1. Remember, this is our parent function with no shifts. We'll talk about the shifts and things later. And what else do we need to talk about? Amplitude, period length. There is no shift. It begins at 0 and goes to the right. The cosine function also has a period length from 0 to 2 pi, but its period starts at the top at 0 and goes down to the bottom and then back up to the top. It still is one period length. It still starts to repeat after 2 pi, and it still has an amplitude of 1. That's a comma. So our sine and our cosine both have the same period length and the same amplitude. They just have a different starting point on the graph. So that's our basic sine and cosine. So from this we can also say that the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. So we can get some of our trig values from looking at our parent function graphs. One other thing that we should mention here, we've been talking a lot about even and odd functions. If you look at our sine function, does it reflect around the y-axis, around the origin, or neither? It looks to me like it reflects around the origin. Sine is an even function. Cosine, on the other hand, if you look, is a reflection on the y-axis. It flips from one side to the other, so it is an odd function. In other words, the sine of x is the opposite of the sine of negative x, whereas cos of x is exactly the same as cos of negative x. So even and odd functions for our sine and cosine. Okay, there are several ways to find sine and cosines of some of our special angles. So one way is to use SOHCAHTOA, and this is based on right triangles only. So if you have a right triangle, and actually I'm going to draw this a different way. Hold on one second because I want to relate it to our unit circle. Okay, so again, this is for right triangles. So if I have a right triangle that looks like this, and I am looking at this angle, I'm going to call it angle theta. The sine is the opposite over the hypotenuse. The cosine is the adjacent length over the hypotenuse, and the tangent is the opposite over the adjacent. Now, if we put this onto a Cartesian plane, if we draw a y and an x-axis through here, and we're still using this triangle, now this point is the ordered pair a comma o, or in other words, x comma y. So this distance is my x value. This distance is my y value. So now I can say that sine of theta is y over, and I'm going to change this to a radius. And we're going to call it the radius of a circle. So let's go over and look at our unit circle. The unit circle is exactly what I've drawn here, where the radius is always 1. So over here, if I'm looking for the sine of pi over 6, which is this angle measure, the sine in my triangle is opposite over hypotenuse. This point is root 3 over 2 comma 1/2. So the opposite is the y value. That is my sine value. And since the radius is always 1, I don't have to worry about the length of the hypotenuse. So when we move to this circle, we can say that the sine of theta in the unit circle is always going to be the y value, and the cos of theta in the unit circle is always going to be the x value. Okay? If the circle does not have a radius of 1 and you have ordered pairs, then we are going to say the sine is y over r and the cosine is x over r. So the unit circle gives us the sine and the cosine of all of these special angles. Any of the ones that are on the axes, those are called I've lost my word. I will think of it and let you know. Anything on an axis, and anything that's related to pi over 6, pi over 4, or pi over 3. Quadrantal angles, that's what they are, sorry. Quadrantal. So a quadrantal angle is any of the angle on one of the quadrant axes, or in between the quadrants. The last way is to use two special triangles. So one of our triangles has to do with pi over 6 and pi over 3 angles. And the ratios of the sides of this triangle are 1, 2, root 3. So using SOHCAHTOA with my special triangles, I can say that the sine of pi over 3 is going to be the opposite over hypotenuse, in this case root 3 over 2. And if we go to the sine of pi over 3 on this chart, there's my pi over 3, sine is my y value, it is root 3 over 2. So I can also do any of my functions with pi over 6 using this triangle. The other triangle is my pi over 4, my isosceles right triangle, and the side lengths here are 1, 1, root 2, and that would give me the same as the values off the unit circle for pi over 4. So whatever way you use is fine with me, but you do need to be able to identify the sine, the cosine, and in a second we're going to talk about tangent, cotangent, cosecant, and secant. So based on either the unit circle or the special triangles using SOHCAHTOA, you should be able to find the sine, the cosine, tangent, all of the trig functions of these special angles. Okay, so here are our other trig functions. We've already talked about sine and cosine. We already said that sine, and I like to use theta so that we can use our xy ordered pair. Our sine of theta is y. Our cos of angle theta is x. So tangent becomes y over x also. Cotangent is x over y. Tangent is also, as you notice, the reciprocal of cotangent. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Okay? We had some other identities that you looked at in pre-calculus. Pythagorean identities. Sine squared x plus cos squared x equals 1, and 1 plus tan squared x equals secant squared x. These and all of the ones on the last screen you should know by heart. The double angle identities, I don't know whether you had to memorize those last year or not. We used them some. The half angle identities, please write them all down. We will not use these as frequently, and you will be able to look them up. So pause the video and get all of those written down. And then our sum and difference identities. And again, these we do not use a whole lot, but write them down in your notes. You will not have to memorize them, but you will be using them some. So pause and write those down. Okay, let's look at graphing a trig function. This one has some shifts and amplitude changes, period changes. So let's remember for sine that our basic period was 2 pi. If we have a change in the period length, we are going to calculate it by using the formula 2 pi over b. The amplitude will be calculated using what we call the a value. Our shift is hk. Now there's no a's, b's, or hk's in here, so let's write a parent function. F of x equals a times, let's try and get that back. Okay, a times the sine of b times x minus h plus k. H is my right and left shift. K is my up and down shift, just like any function that I've been using. So this is almost in that form. I need to factor out this 2. So I'm dividing both of these by 2, so that makes this pi over 6. There is no plus k here. I'm going to write a plus 0 just so that we remember that we need to look at that. So when we graph a function, this is the order that I think is easiest to do things in. The first thing that you want to do is do your up or down shift. And you know what? I think we'll go back and add a plus 1 to this just so that we can practice this. So just change your function. So we're going to go up 1 unit, and that is going to become my new center axis. Okay? The next thing that I suggest doing is the amplitude. The amplitude is how far up and down I go from the middle. In this case, my amplitude is 2. So I'm going to, from my central axis, I'm going to go up 2 to 3 and down 2 to -1, and that will be my top and bottom. So now I know top, middle, and bottom for my function. The third thing I would suggest is your right and left shift. That comes from my h value, in this case -pi over 6. Remember that right and left shift is always the opposite. So I'm going to go to the right pi over 6 units, and that's going to be where my function begins. Not at 0, but to the right pi over 6. The last thing I want to do is my period length. And we said the period is 2 pi over b, in this case 2, so pi units. So from my pi over 6, I want to go pi units to the right. So if I take pi over 6 and add pi to it, I'm going to keep my denominator, pi over 6 plus pi, which would be pi over 6 plus 6 pi over 6, a common denominator to add. So 7 pi over 6 is going to be where my period ends. Now I need a few critical points. I've got my endpoints already. I need some critical points. So I need middle. What is halfway between? What is halfway between 1/6 and 7/6? Hopefully you can add 1 and 7 and divide by 2 and get 4/6. We could also call that 2 pi over 3. What's halfway between 1 and 4? Ooh, that's a little trickier because I would get 2 1/2/6. That's not going to work. I need to go to 12ths. So to find my midpoint here, I'm going to say 2 12ths to 8 12ths. 2 plus 8 is 10. That gives me 5 is the midpoint. 5 pi over 12. So let's see what happened. If this is 2 12ths, I added 3 12ths to get to here, 5 12ths. 3 more 12ths puts me to 8 12ths. 3 more, 8 plus 3 is 9, 10, 11 pi over 12. and 3 more would be 14 pi over 12. So if I take it to the smallest denominator and count out, each section is equal. So I've got all of my points that I need. Sine looks like this: middle, top, middle, bottom, middle. So starting with pi over 6 at my middle, I go to the top, back to the middle, I go to the bottom, and back to the middle. And that's enough to draw my graph. Okay, we'll practice some more of these, but that is it for the video.